Good afternoon, everyone. This is Tushar Daspatnaik, lecturer in Metallurgical Engineering, Odisha School of Mining Engineering, Keonjhar. For the next 25 to 30 odd minutes, I will be taking your class on mechanical metallurgy, which is a 6th Sem subject. The subject code is MTD 602. I'll be giving brief about the syllabus of it. I'll show the content, then I'll proceed with the subject. We'll go to the next slide. This is a chapter 8 of the syllabus. You can refer, students, chapter 8 of mechanical metallurgy, that is extrusion. I'll be taking your class on extrusion for the next 25 minutes. This is the syllabus. This is the syllabus is prescribed by SATVT. First is explain the elementary principle of extrusion. Second is classify the defects in extruded product. Third is explain the manufacturing of seamless pipe. We'll start with the elementary principle, then we'll move further. We use it every day, isn't it? We use it every day. Paste, toothpaste. What is the function of toothpaste? Actually, we put pressure from the behind and toothpaste comes out. We apply pressure from the back side and toothpaste comes from the front end. If we compare the toothpaste with metal, suppose metal billet is there instead of toothpaste. Suppose metal billet is there. I apply pressure. Obviously not inside a plastic cover. Obviously metal container, obviously. If I apply pressure from the back side or force from the back side, the metal will come out from the front end. The metal will come out from the front end as the shape of the opening. If the opening shape is circular or cylindrical, the product will be cylindrical. If it is rectangular, the product will be rectangular. Isn't it? That is extrusion. That is extrusion. Extrusion is basically, what will the definition of it? If we can deduce from this picture, it is the process of pushing the metal billet through a die under high pressure. This mouth of the toothpaste, the toothpaste can act as a die. If I can replace this mouth with two dies, that will suffice. That will give us idea about extrusion. The next slide I'll explain the actual process, what happens in real time in case of extrusion. You can compare. Inside there is toothpaste. This is billet, metal billet. I apply pressure from the back side through by using a ram, solid ram. This is the two die. This is a cross-sectional view. That means if I cut the system, what it will look like. Okay. If I apply pressure from this side, the metal, obviously the die is in cylindrical shape. I mean the opening. If you apply the pressure from the back side, the billet or the extruded product will come from the front end. That means I am applying pressure from the back side. Because of the high pressure, the product is coming out through the opening, and the opening shape will decide what will be the final product. If this is cylindrical, the product will be cylindrical. If this is square or rectangular, then the product will be rectangular. Okay, this is extrusion. We can compare it with toothpaste. That will be easier, as easy as you like. This will be extremely easy to understand if you can imagine the function of a toothpaste. That will be extrusion. Okay. Why we study extrusion basically? That's very important. We study so much, but we must know the practical aspect of it. Why we study extrusion? Okay. But the application of it, this is the day-to-day life stuff. Whatever, there are a lot of applications. I have picked up 2-3 stuff. This is cold drinks can, everybody use it. Cold drinks can. This is case of a fire extinguisher. This is the automatic pistons that is used in every motorbike. So these are made by extrusion process. So extrusion has an important role in day-to-day life. Okay. Now we can give importance to extrusion. Why we can study extrusion? Because it has great importance in our day-to-day life. Do you understand, students? Move to next slide. That is types of extrusion. There are two kinds of extrusion. One is direct extrusion, another one is indirect extrusion. This classification is based on application of force and the removal of product or the direction of extruded product. Based on that, these two extrusion processes have been classified. First, I'll explain direct extrusion and indirect extrusion simultaneously. Okay. Look at this. This is a solid ram. This is a billet. This is the container. This is the die. I'm applying force from this side. The extruded product comes out from the same side, that is in the direction of force. I'm applying force from this side. The extruded product comes in the same side or in the same direction. This is direct extrusion. The application of force and the product, the direction of product are in the same direction. However, in case of indirect extrusion, I apply force from this direction, the product comes in the opposite direction. Can you get me, students? We apply from this direction, the product comes in that direction. Okay, that means we have to use a hollow ram. So that I'm pushing the metal, the product will come out through the hollow ram. Can you get the difference? This is the major difference. The force and extrusion product in the same direction, direct extrusion. Force and the product in the opposite direction, that is indirect extrusion. What is the other major advantage or disadvantage of it? In case of direct extrusion, I can apply more load because of solid ram. It is solid. However, in case of indirect extrusion, I use hollow ram, so I can't use maximum load here. The material which needs maximum load or maximum pressure can't be extruded by indirect extrusion. Are you getting me? Okay. In case of direct extrusion, the friction between billet and container, billet and die is higher. So there will be severity of deformation. Severity of deformation will be more here. Chance of crack or chance of material failure will be more in case of direct extrusion. However, in case of indirect extrusion, there won't be any relative motion between billet and container. This is a container, this is a billet. Hence, severity of deformation will be less. Chance of material failure will be less. Okay, do you understand the major difference between direct extrusion and indirect extrusion? Okay. Next, we will go for some technical term, that is how extrusion is defined. Extrusion defined by a technical term that is called extrusion ratio, which is defined as the ratio of initial cross-sectional area to final cross-sectional area. Like, suppose initial cross-sectional area is 5 mm or 10 mm and final cross-sectional area will be suppose 2 mm. Then what will be the extrusion ratio? That will be 5 division 2. That is 2.5. Okay. I have given some example. For steel, extrusion ratio R will be 40:1 or 40. For aluminium, it is 400:1. Okay. Okay, we'll go for next slide. Now we study extrusion defects. What are the extrusion defects? There are 4 extrusion defects out of many number defects. I have picked these 4 important defects that happens in case of extrusion. First is internal oxide stranger. Second is axial hole. Third is surface crack. Fourth is center burst or chevron cracking. Center burst or chevron cracking. Okay, we'll study first internal oxide stringer. As the name suggests, it's a stringer. Stringer means like a staircase. You know, if you look a staircase from the back side or a side view, you get this kind of, okay, like a staircase. So stringer, oxide stringer means metal oxide stringer. How does it form in case of extrusion? As the force is applied from the back side, the center material comes out early, then the edge material. The center material comes out early, then the edge material. So center gets colder faster than the edge material. So there is a chance this edge materials becomes oxidized. And when we push further the ram, these edge materials get extruded through this extrusion product. Oxides, basically metal oxides, are brittle in nature. If they get entrapped inside the metal, it will create brittleness inside the metal or whatever product we are generating. Okay, that is why it has to be removed. What is the remedy of it? Remedy is heat the container so that we can maintain uniform temperature throughout the cross section, so that rate of oxidation will be reduced. Number 2, what is the thumb rule? Now after 2/3 of the billet is extruded, stop the extrusion. Again put new billet and start extrusion afresh, so that whatever product we will get, that will be defect free. Next is put a dummy block over there. Next remedy will be put a dummy block over there, so that what will happen, if you put the dummy block, this edge materials, this black portion, you can see this black portion, this, suppose these are the edge materials. If you apply the force, these edge materials doesn't get extruded. If the edge material doesn't get extruded, so there is no chance of formation of oxide stringer. Okay, so this is the advanced way to put a dummy block and do extrusion. Okay, so internal oxide stringer, cause and remedy we have discussed. Cause is center moves faster than the edge, so center gets colder faster than the edge gets oxidized. What is the remedy? Remedy is heat the container. Number 2 is after 2/3 of the billet is extruded, stop the extrusion. Number 3, which is the important one, put a dummy block. Put a dummy block so that the edge material doesn't get extruded during extrusion. Clear? Clear? We'll go to next defect, that is axial hole. As the name suggests, axial hole, there is a hole along the axis. What is the cause of it? If center moves faster than the edge, if the center material, if this is the die, this is the billet, if you apply force from this side, okay, if you apply force from this side, if center moves faster than the edge, like suppose my ram travel is faster, my ram travel is faster, so my ram speed is faster, I am pushing harder, that means my center will move faster and eventually it will form hole. First step, second step, third step, because center is moving faster. in the third stage, eventually it will form hole along the axis, central axis of the extruded product. Okay. What is the remedy? Remedy is correct speed of ram travel. Ram travel should be proper. Okay. Or another one can be stop the process if you can't control the movement of ram travel. Two remedies basically. One is correct speed of ram travel. Second is if you are unable to control the ram travel, stop the process. Otherwise, this defect will be inside the extruded product. This defect will be inside the extruded product, which is not good for quality. Okay, get it? Next we'll go for surface crack. This is a real picture of a extruded product. See the cracks, surface cracks. See the surface cracks. What is the cause of it? Because of high temperature, surface temperature, or high extrusion temperature and high ram speed. These surface cracks occur because of high extrusion temperature and high ram speed. Friction between die and the metal billet, friction between die and metal billet, if higher, can generate surface cracks. So we have to be aware of the fact that extrusion temperature, ram speed and friction must be taken care of during extrusion so that we can avoid surface cracks, because surface cracks are very common, absolutely common in case of extrusion. So we have to reduce that. How can you do that? What is the remedy? Proper extrusion temperature should be maintained, proper lubrication should be done, and ram speed should be correct as per the calculation. As per the extrusion ratio, the ram speed should be correct. Otherwise, we'll get this kind of cracks all along the surface of the metal billet. Okay. Next, we'll go for center burst or chevron cracking. This is a very, very important defect in case of extrusion. Okay. First is this chevron. Chevron means V-shaped crack. If in during extrusion, if friction is higher or extrusion ratio is low or die angle is higher, that means the billets try to gust through the center. The center develops tensile stress. At the center there will be tensile stress develops. There will be stretching kind of effect that will generate at the center. Eventually it will form V-shaped cracks. What will the remedy? Extrusion ratio should be proper, die angle should be proper. We understand? The 4 defects we have studied. We'll go for next. Manufacturing of seamless pipe. This is the last end of for this chapter. This is manufacturing of seamless pipe. First we'll understand what is a seamless pipe. There are 2 kinds of pipe. One is welded pipe of seam pipe. Another one is seamless pipe. Look at this picture. This is a welded pipe. We take a flat sheet, bend it, join it and weld it. You get a seam. That is a seamed pipe or welded pipe. However, these are seamless pipe, like you use in our curtains. With curtain you use the seamless pipes. We'll try to manufacture this seamless pipe with this procedure. Let's first classify the pipes. Pipes are 2 kinds: metal pipe or plastic pipe, non-metal pipes. Metal pipe can be divided into 2 types: seamless pipe and seamed pipe. Seamless pipe you can see it. Welded pipe you can see it. For non-metals, that's plastics, this PVC pipes that is used in case like in our wiring, electrical wiring, this PVC pipes are used. Okay. Next we'll look for next slide. This is the procedure of it. How can we generate a seamless pipe? There's 4 different kinds of mills are used to generate a seamless pipe. One is management mill, next step is plug rolling mill, next is 3-roll piercing mill, next is rilling mill. This is a barrel shaped roll is used. This is the mandrel. This is a barrel shaped roll is used to form primary tube from the billet. Next step, to form finished tube, like the thickness of the tube is reduced. In case of plug rolling mill, we use a plug with 2 cylindrical rolls. Next step is 3-roll piercing mill. We use 3 rolls, 1, 2 and 3 to convert the tube into pipe or to make more concentrated and smoother pipe. In the next step, that's rilling mill polished. We use 2 different cylindrical rolls to get polished pipe. This is the overall procedure to produce seamless pipe. Okay, these are the assignment questions for you students. First one is explain the principle of extrusion with neat sketch. Differentiate direct and indirect extrusion. What are extrusion defects? Write down the causes and remedies. Number 4, explain manufacture of seamless pipe with neat sketch. Sketch is very important. If you want to get good marks, to have a good impression on your evaluator, you have to draw neat sketch. Number 5, what are the application of extrusion that we discussed at the front end. Okay, any doubts, you can WhatsApp me on this number 9861179877, or you can mail me on this email ID.
स्कूल छोड़े हुए 2 साल हो गए यार, अभी तक कॉलेज का नामो निशान नहीं है। कम से कम फेल हो जाते तो स्कूल में ही रहते।
सही बोल रहा है यार तू, यहाँ तो रोज़ रोज़ बाप के डंडे खाने पड़ते हैं।
एक तरफ बाप और एक तरफ किस्मत, दोनों तरफ से तो डंडे पड़ रहे। ज़िंदगी तो ख़त्म सी लग रही है।
ज़िंदगी का तो पता नहीं, लेकिन ये मूंगफली ज़रूर ख़त्म हो गई है। ये ले लास्ट है, देख देख।
तू भिड़ जा, तू लड़ जा, तू अड़ जा, तू कर जा, झूम झूम के घुमा तेरा हुनर का ये डंडा। नहीं है तो पकड़, नहीं है घुमाकड़, अगर मगर मकर तू तो टक्कर का है बंदा। तू गिरेगा, तू फंसेगा, तू रुकेगा, चल
बेटा, कोशिश करने वालों की ना हार नहीं होती।
तू भिड़ जा, तू लड़ जा, तू अड़ जा, तू कर जा, झूम झूम के घुमा तेरा हुनर का ये डंडा। देखो लोकंकर काम हैला कथा हेबे कला कौशल नुआ सृष्टिर से मजा नेबे। तमे हेलो गोटे अतांक बळी हजार हेबे, सीए प्रजा किंतु तमे सब रजा हबो। जीवन तो गोटे स्वप्न बास्तवतार जे स्वप्न उठे, सब किछि संभव विथ काम आउ कौशल। जीतिगिरी मिले बहु बळी बहु बळ। तू करी जा, तू लड़ी जा, तू बड़ धन, तू हेलो स्किल देन ओडिशा। तू करी जा, तू लड़ी जा, तू बड़ी जा धन, तू हेलो स्किल देन ओडिशा। स्किल देन ओडिशा, स्किल देन ओडिशा, स्किल देन ओडिशा धन, तू हेलो स्किल देन ओडिशा। दुनिया वाला तू मिला तो ये खोलेगी, तेरा राजू पे ये तोलेगी, हर मौके पे ये टोकेगी। करना फिकर बस अब आगे तो बढ़, किस्मत को कोस मत, साथ है हुनर। जो करना है कर, अब भुला दे तू डर, आसमां को छू ले फैला के तू पर। सुनो सुनो देखो कथा हबाकू अनेक लोक आज दुनिया रे, किंतु लाभ कौन तुमको तांको कथा सुनी बारे। बुझो एई कथा की तो चढ़ई दौड़ी चले जाकी पचारे मोना कौन ओडिशा रे। तमे हेलो ओडिशार कौशल भूली बनी, तमे हेलो ओडिशार कौशल। बयस रे कम किंतु हब तमे बहु बड़, तमे सब कर ओडिशा को गौरव। तू करी जा, तू लड़ी जा, तू बड़ धन, तू हेलो स्किल देन ओडिशा। तू करी जा, तू लड़ी जा, तू बड़ी जा धन, तू हेलो स्किल देन ओडिशा। स्किल देन ओडिशा, स्किल देन ओडिशा, स्किल देन ओडिशा धन, तू हेलो स्किल देन ओडिशा। झूम झूम के घुमा तेरा हुनर का ये डंडा, हुनर का ये डंडा। झूम झूम के घुमा तेरा हुनर का ये डंडा, स्किल देन ओडिशा। तू करी जा तू लड़ी जा तू बड़ धन तू हेलु स्केल दिन ओडिशा तू करी जा तू लड़ी जा तू बड़ी जा